Hello, today we are going to discuss panel data regression. What is panel data regression? What are the issues in panel data regression? And how we do panel data on Eviews. These are the major talks which I am going to do today. See, panel data, also known as longitudinal data, have both time series and cross-sectional dimensions. See, historical as well as cross-sectional. Say I have 5 companies, 6 companies, I have got their profits, and these profits are for say 10 years. So I can take the company-wise yearly data and profits of the companies for 10 years. And then for all 10 companies, if I am using it, so that will become a panel. They arise when we measure the same collection of people or objects over a period of time. Econometrically, the setup is YIT. I means for the company and T means for the time. So model will be alpha plus beta XIT and your error term of IT, because error term will be for each year and as well as for the company. Where YIT is the dependent variable, alpha is the intercept term, beta is a k into 1 vector of parameters to be estimated on explanatory variables. So XIT. T means time from 1, 2, 3, 4 up to T. I means number of companies. The simplest way to deal with the data would be to estimate a single pooled regression on all the observations together. That's the most simple. You don't do anything, simply run normal data without anything, simply run it, and we call it pooled data regression. But pooling the data assumes there is no heterogeneity. That is, same relationship holds for all the data. Everything is same. All companies are same. Only yearly data is coming up. So everything is same in pooled data. But usually this does not happen because every company is different. So when all companies are different, behaving differently, so how pooled data can be a good regression? There may be balanced and unbalanced panel. In microeconomic panels, the individuals are not always interviewed the same number of times, leading to an unbalanced panel. See, sometimes we for a particular company or for a particular period or for particular this, we do not survey all equal numbers. Some unbalanced panel, the number of time series observation is different across individuals. Some data for say I'm taking Reliance, it may be 5 years. I'm taking HUL, it may be 10 years. If I'm taking this other company, it may be 7 years. In a balanced panel, each individual has the same number of observations. So balanced and unbalanced panel sometimes can. Now, what are the benefits of panel data? First advantage, basically the advantage is that we are to see what is happening commonly among all the companies or all the individuals. There are a number of advantages from using a full panel technique when a panel of data is available. We can address a broader range of issues and tackle more complex problems with panel data than would be possible with pure time series or pure cross-sectional data. Because we mix it up and we find to see what is common in among all the companies or what is different in all the companies. It is often of interest to examine how variables or relationship between them change dynamically over time. By structuring the model in an appropriate way, we can remove the impact of certain forms of omitted variables bias in the regression results. So we can omit that. That is also there. Now, for instance, I give you the example of panel data. Say I have got 5-6 states. For each state, say for instance, Andhra Pradesh, I have got 5 years data from 1991 to 1995. I have got their state GDP. I have got the debts, capital expenditure. So I am interested whether SGDP depends upon debt and on capital expenditure or on both. So what is common among all the states? But is there anything common among all the states? So for instance, Bihar, Goa, Gujarat. So I can see the data of this. So this will be yearly data for Andhra Pradesh, 5 years data for Bihar, 5 years data for Goa, 5 years data for Gujarat. This has been given. So this kind of is panel data. But when you are to present data to Eviews or any other software, it needs identification, it needs indexing. So we create an index so that we are to, for every state, we have written 111, 222, 3333. I will tell you how to create this index in Excel. I will tell you how to create this index in Excel before we upload to Eviews. Now, method 1. Method 1 is very simple. It is simply a pooled least square model. You don't need to do anything, just run the OLS. And this one is YIT is equal to B1 plus B2 X2 IT, B3 X3 IT, and error, where the data on different individuals are simply pooled together with no provision for individual differences that may lead to different coefficients. Notice that the coefficients B1, B2, B3 do not have I or T subscripts. So they are simply, you are going to get only one B1, only B2, only B3. For all data, simple regression, you will get only coefficients. The data for different individuals are pooled together and the equation is estimated using least square. That is pooled data. Now, what are the consequences of using pooled least squares? The least squares estimator is consistent, but its standard errors are typically too small, overstating the reliability of least squares estimator. Standard errors are very small. It means the T value may be very high, T stat may be high. There may be unrealistic assumptions. All individuals have the same coefficients. How it is? It may not be. But we in the pool data, we consider that all coefficients are same. The errors for different individuals are uncorrelated. So there is no correlation between the error. These are the basic consequences of pooled least squares. Now, next method is fixed effect model. This you have to understand this. What is fixed effect model? The equation 1, which we have written in the first slide, this equation YIT B1, B2, BX2 IT, B3, X3 IT, and error term can be rewritten as YIT B1I That is for states. When we have taken up the examples of state, this B1 is constant, which is constant, that may be constant for each state. Similarly, for each state, there can be a different B2. For different state, there can be different B2. A legitimate panel model above equation 2 is not suitable for short, only 5 time series observation, and wide panels need a simplification. So this can be, this equation 3 is, again, we are writing it as B1I, that is only state-wise, B2I, B3X3I error terms. The intercepts BI2 are different from different individuals, that is different states in which we are going to use the example. But the slope coefficients B2, B3 are assumed to be constant for all individuals. For every state, constant will be different. Constant will be different. Now, all behavioral differences between individuals referred to as individual heterogeneity are captured by the intercept. Now, all individuals, how individuals are behaving and their heterogeneity is captured by the intercept. Individual intercepts, which are B1, or sometimes we quote it as alpha 1, individual intercepts are included to control for individual specific and time invariant practices. For instance, gender, race, education, etc. All model with these features is called fixed effect models. Fixed effects estimator is unable to estimate coefficients on time invariant variable like race, gender, etc. Now, method 3, a random effect model. In the random effect model, see, assumption is we are not selecting all the states, or we are not selecting all the companies, or we are not selecting all the individuals. We have selected individuals randomly. We have selected the individuals randomly or states randomly. So that randomness should come in the model, or is to come in the model. In the random effects model, we recognize that individuals were randomly selected, and thus we treat the individual differences as random rather than fixed. Because these individuals which we have selected, the companies, the states which we are selecting at random. We tell the system we have not selected it all, we have selected randomly. We can include random individual differences. What are the differences randomly? What is the difference randomly in all the individuals? By specifying the intercept parameters to consist of a fixed part that represents the population average. And by specifying the random individual differences from the population average, we can say the constant, which was B1I. Actually, there is a mean, B1I bar, that is the mean plus error. So we are actually in random effect model, we are taking the means of the constant, and the error goes to the error part. So constant is the constant which comes in the model, that is the mean of those constants. The random individual differences, errors are called random effects, that is random individual effects or random error terms. If random effects are present, then the random effects estimator is preferred for several reasons. The random effects estimator takes into account the random sampling process by which the data were obtained, because we have taken up the samples. The random effects estimator permits us to estimate the effects of variables that are individually time invariant. Time invariant. Time is not different with the time. The random effects estimator is generalized least square estimation. Now it is not OLS. It is GLS. It is not OLS, it is GLS, estimation procedure. And the fixed effect estimator is a least square estimator, that is OLS. In large samples, the GLS estimator has a smaller variances than LSC, because the generalized least square method that has got a smaller variance than least square methods. If random error, say random error is VIT is equal to U plus EIT, is correlated with any of the right-hand explanatory variables in random effect models, then the GLS estimators of the parameters are biased and inconsistent. So if there is any correlation, then there is a biasness in the system. The problem is common in random effect models because the individual specific error component may well be correlated with some of the explanatory variables. So the error term may be correlated with the explanatory variables. A person's ability and industriousness are variables not explicitly included in the wage equation. Thus, these factors are included in error term. See, I am thankful to those who have worked hard on these topics. So these slides are being used from those who have written the books on the topics, those who have worked hard on the topics. So I will see that I give my references to those people whose slides I am going to use. These characteristics may be correlated with this education level or job experiences. Random effect estimator is inconsistent. To check for any correlation between the error component, random individual effects, and the regressors in random effect model, we can use Hausman test. Basically, Hausman test tells us whether we should use fixed effect model or random effect model. And Hausman test actually sees if there is any correlation of the error term with the regressor, with the regressor. The Hausman test can be carried out for specific coefficients using a t-test or jointly using an f-test or chi-square test. It's a combination. So it uses, the idea for Hausman test is both for random effect and fixed effects estimators are consistent if there is no correlation between the error terms and the explanatory variables. The null hypothesis for Hausman test is that difference between the estimators is 0, two-tail test. And if we reject the null hypothesis, then we use the fixed effect estimate. It means for null hypothesis, we say random effect is there. And if null hypothesis is rejected, we use fixed effect estimate. Let the parameters of interest be beta. Denote the fixed effect estimator as BFEK and the random effect estimate as BREK. The T statistic for testing, there is no difference between the estimators is, say T-stats formula. It's a simple T-stats formula. So B, beta, which we are getting as fixed effect, minus beta as we are taking it as random effect, divided by variances of beta, which is fixed effect minus beta of random effect, and we take the square root. It will give you the ultimately standard error. So T-stat is basically B upon standard error of B. So we have taken the differences and then that we have taken up the standard error. This is the way Hausman test works. Now I repeat, types of models for panel analysis. First, we do the pooled least square estimation method. Eviews 10 and above, that tells you, because there is a test which we can use, whether we can use pool test or should we use fixed or random effect model. We can use it, but in earlier models, Eviews 7 or earlier. So that test is not there. So you will have to directly apply whether fixed effect or random effect. The method 3, a random effect model. In the random effect model, see, assumption is we are not selecting all the states, or we are not selecting all the companies, or we are not selecting all the individuals. We have selected individuals randomly. We have selected the individuals randomly or states randomly. So that randomness should come in the model, or is to come in the model. In the random effects model, we recognize that individuals were randomly selected, and thus we treat the individual differences as random rather than fixed. Because these individuals which we have selected, the companies, the states which we are selecting at random. We tell the system we have not selected it all, we have selected randomly. We can include random individual differences. What are the differences randomly? What is the difference randomly in all the individuals? By specifying the intercept parameters to consist of a fixed part that represents the population average. And by specifying the random individual differences from the population average, we can say the constant, which was B1I. Actually, there is a mean, B1I bar, that is the mean plus error. So we are actually in random effect model, we are taking the means of the constant, and the error goes to the error part. So constant is the constant which comes in the model, that is the mean of those constants. The random individual differences, errors are called random effects, that is random individual effects or random error terms. If random effects are present, then the random effects estimator is preferred for several reasons. The random effects estimator takes into account the random sampling process by which the data were obtained, because we have taken up the samples. The random effects estimator permits us to estimate the effects of variables that are individually time invariant. Time invariant. Time is not different with the time. The random effects estimator is generalized least square estimation. Now it is not OLS, it is GLS. It is not OLS, it is GLS, estimation procedure. And the fixed effect estimator is a least square estimator, that is OLS. In large samples, the GLS estimator has a smaller variances than LSC, because the generalized least square method that has got a smaller variance than least square methods. If random error, say random error is VIT is equal to U plus EIT, is correlated with any of the right-hand explanatory variables in the random effect models, then the GLS estimators of the parameters are biased and inconsistent. So if there is any correlation, then there is a biasness in the system. The problem is common in random effect models because the individual specific error component may well be correlated with some of the explanatory variables. So the error term may be correlated with the explanatory variables. A person's ability and industriousness are variables not explicitly included in the wage equation. Thus, these factors are included in error term. See, I am thankful to those who have worked hard on these topics. So these slides are being used from those who have written the books on the topics, those who have worked hard on that topics. So I will see that I give my references to those people whose slides I am going to use. These characteristics may be correlated with this education level or job experiences. Random effect estimator is inconsistent. To check for any correlation between the error component, random individual effects, and the regressors in random effect model, we can use Hausman test. Basically, Hausman test tells us whether we should use fixed effect model or random effect model. And Hausman test actually sees if there is any correlation of the error term with the regressor, with the regressor. The Hausman test can be carried out for specific coefficients using a t-test or jointly using an f-test or chi-square test. It's a combination. So it uses, the idea for Hausman test is both for random effect and fixed effects estimators are consistent if there is no correlation between the error terms and the explanatory variables. The null hypothesis for Hausman test is that difference between the estimators is 0, two-tailed test. And if we reject the null hypothesis, then we use the fixed effect estimate. It means for null hypothesis, we say random effect is there. And if null hypothesis is rejected, we use fixed effect estimate. Let the parameters of interest be beta. Denote the fixed effect estimator as BFEK and the random effect estimate as BREK. The T statistic for testing, there is no difference between the estimators is, say T-stats formula. It's a simple T-stats formula. So B, beta, which we are getting as fixed effect, minus beta as we are taking it as random effect, divided by variances of beta, which is fixed effect minus beta of random effect, and we take the square root, which will give you the ultimately standard error. So T-stat is basically B upon standard error of B. So we have taken the differences and then that we have taken up the standard error. This is the way Hausman test works. Now I repeat, types of models for panel analysis. First, we do the pooled least square estimation method. Eviews 10 and above, that tells you, because there is a test which we can use, whether we can use pool test or should we use fixed or random effect model. We can use it, but in earlier models, we use 7 or earlier, so that test is not there. So you will have to directly apply whether fixed effect or random effect. So we will see fixed effect model or random effect model. Fixed effect model is OLS, random effect model is GLS. Random individual differences, they are reflected by random effect model. And error terms are correlated with explanatory variables, that is shown by fixed effect. So error terms are correlated with the explanatory variables. So then we use fixed effect model, and which one we should use, that is told by Hausman test. Hausman test is fixed effect and random effect estimators are consistent. No correlation between error term, the explanatory variable. So accept the null hypothesis, that is FE is equal to random effect, select the random effect model, and reject the null hypothesis when FE is fixed effect is not equal to random effect, select the FE model. So fixed effect model. That is the way we do it. So first we try. The main problem in this panel is preparing the data. It's a lot of work because you can individually download the data from any site. You can individually take the data from any source, but then you have to adjust it. And the data should be more than 40, 50 observations. If the observations are less, then the question of degree of freedom will come. So we will always have a large data. so that the degree of freedom question should not come, and the system should be able to properly analyze it. At least 40-50 observations should be there. First, we do the pooled regression, normal regression, and then we do it with the fixed effect. Then we do it a random effect. Hausman test is done on random effect, and random effect, if it is rejected, we use fixed effect, and then the model comes up. Now let us go to the Eviews for practical. I will first show you the data on Excel sheet. You can see the Excel sheet. In Excel sheet, we have taken up the states, the year, state GDP, debts, capital expenditure, then social sector expenditure, the grants given by government. Then we have taken up the ratio of debt to GDP. So this is debt divided by state GDP. Similarly, we have taken up ratio capital to GDP. So this is capital expenditure divided by SGDP. Similarly, we have social sector expenditure. We have divided by SGDP. So this is the ratio. So all these ratios have also been given for the calculations. Whichever is okay for you, you can use it. And then we have taken up the time variable for each year. Say now 18 years is the data for Andhra Pradesh, 28 years. Similarly, 20 years data is for Bihar, then 28 years data for Goa, then all data are given for this. I have taken up 5 states. For each state, there is a data for 28 years. So data starts from 1991 to 2018. Now, we need to index it. So I just simply tell you how we can do that. In CAID, you can simply write down 1 here. In this first row, just write down 1. Now, in the second row, you can write down if B3, this B3 is equal to B2. B3 is equal to B2. B3 is equal to B2. Then you write down A2, that is 1. Otherwise, you write down A2 plus 1. So this is the formula I have used to create the CIT. Since this all data 1, 1, 1 will come, but as you go here, Bihar, it will, because this Bihar is not equal to Andhra Pradesh, so it is automatically adding 829 plus 1. So if B3 is equal to B29, it will write 829, but Bihar is not equal to Andhra Pradesh, it has done 829 plus 1. So this is the way you can create this. Sometimes you will have to do this exercise in Excel only. Now let us open this data. Let us open this data in Eviews. In Eviews, I have opened this data. So it is coming as CIID, state, year, and then the data is coming as SGDP, and up to so many decimals it is showing. So debts, capital expenditure, then all ratios which are there, and then time period. Okay, so we have got this. Let me open this. Open, and these are all my C index, and then I can see the capital expenditure. I can open it. Okay, so this one is gone. So let us see. Now, first step, we have to test the unit root. Unit root should be tested. Now let me see the SGDP. This one, SGDP. SGD, state GDP. I will go to quick. The first step is to test the unit root. Now in parallel regression, the unit root testing is done by many methods. Many methods. Let us see series statistics, unit root, And I will write the series name here, SGD. I'll say OK. Now it asks me which method I should use. Should I use Levin Lin Chu? Should I use Britrung? Should I use I'm Pesaran Shin, Fisher ADF, Fisher PP, or Hadri? Now, in all the methods, null hypothesis is it has unit root, except Hadri, Levin Lin Chu, Britrung, I'm Pisaran Shen, Fisher ADF, Fisher PP, they all have the null hypothesis. There is unit root, and alternate hypothesis, there is no unit. But in case of Hadri, it is opposite. It has no unit root, null hypothesis, no unit root, then it has got alternate hypothesis, that's unit root. So instead of this, we will do, instead of selecting one, let us do the summary. Now in summary, we will, instead of using the use specified one, we will see automatic selection lags, and we will do the level. First, we test it as level, and we will do it with none. Now this exercise you will have to do many times, first with none, then with the individual intercept, then with the individual intercept and trend, and then with first difference, none, individual intercept and trend, and then second difference with all the threes. Okay, so this is a time consuming thing. You'll have to see this. Let us see, we are going to do summary, level, none. So let us see this one. What are the results? Now results are given here, except Hadri. All results are given there. Null is unit root. There is a unit root. So first one is Levin Lin Chu. It is coming as 100%. So data is telling that there is a 100% T-stat is tau stat is 23.6600. ADF Fisher is also coming 100%, probability 100%. Let us see only the Hadri. Let us see the Hadri. What Hadri says? Hadri says we will go to unit root and we will use Hadri and level with the this. He does not allow you to use this one none, but it allows you to intercept, individual intercept. We'll say okay. So Hadri also says because it is there a unit root, no unit root. It means there is a unit root because now Hadri's hypotheses are opposite to the earlier one. So we have got this. Now let us go back to view and we will go to unit root and we will use individual and intercept. We will use the summary again and we'll say okay. Now this is again says all the test says there is a unit root. Hadri, as we have already tested, this is it is a unit root. So let us now do it with the unit root with first difference, individual and intercept by summary. Now the problem is here again. It is not rejecting the null hypothesis. Levin Lin Chu does not reject the null hypothesis because the probability is 0.9945. I am Pearson and Shin also does not reject the null hypothesis. Fisher chi-square, it says 0.4069. Fisher chi-square, it also says 0.3698. So they do not reject the null hypothesis. Let us view this. Let us view this unit root with Hadri. Hadri by taking the first difference, individual and intercept. Let us see now. So it is again rejecting the null hypothesis. Means there is null hypothesis, there is no unit root. Alternate hypothesis, there is a unit. Now we will go to view again we will go to review again. We'll say unit root test, and we'll use individual and intercept and trend. And we will use the summary. So this you have to see everywhere. Now here, Levin and Lynchew says it is nearly 0.0585. It has come nearly. There is a unit root is there 0.05. And Brayton T-stat also says there is a unit root. But I'm person, Fisher chi-square, they say there is no unit root. When we use first difference with intercept and time, there is no. These three. So majority of the people out of this 5, majority of the people say there is no unit root. Let us see Hadri, what he says. We will see, go to unit root. We'll go to Hadri and first difference with individual and intercept. We will say okay. And now Hadri says there is, he rejects even that. Hadri stat say probability is 0.00. So there is a unit root. It says there is a unit root. So Hadri even says go for the second difference. Unit root, go for the second difference. So let us say what is the result for Hadri. Now, Hadri stat does not reject the null hypothesis. If we take the second difference, SGDP, second difference, Hadri advises we should use second difference, but all other people, they say we should use first difference with intercept and time. Now it is your creativity. You have to apply your wisdom. Now, if there is a first difference with time, or there is a first difference with the first difference or second difference that you have to use. Now you have to test all the series. It is not simply you are going to test only SGDP. You have to test all the series. We will go to quick pooled panel regression. Go to estimate equation. So estimate equation is, I am going to use it first difference, assuming the data is level at first difference. So I am going to use first difference SGDP. Now, if you have to use the second difference, you can put 2, 2. So it will give you the second difference. But you have to put, I'm going to use it here as SGDP constant, because constant is there. Everywhere constant is there. Then D capital expenditure, first difference. Then first difference is your, I'm going to take as debts, DEBTS, debts by states. And then I can use also time which I have used it. I can also use it as time. You may avoid the time also. That is up to you, how you find out whether the series are at level with time or not time. Now here, least square method. We are going to use the least square method. And to write E, so XP. Let us say, now this one is the equation for us. Constant is 0.11825.58. First difference of capital expenditure is 1.77. This probability for this is statistically significant. Constant is statistically significant. Constant is same for all. Similarly, coefficient for 1.77 is for all. This is a common one because this is a pooled data. Difference debts, so the probability is 0.985. It means debts are not statistically significant for increase in or decrease in SGDP. Because this is 0.18, this is positive. but they are statistically not significant. Time is statistically significant. Time is statistically significant. This is very important, that time is statistically, with the passage of time, as GDP, state GDP grows automatically with the passage of time. But capital expenditure, it is statistically significant, but debts are not. So states which they are taking the debts, they are not actually increasing, or they are not using it for expenditure. Now let us go to view estimate equation. Sorry, go to estimate equation. I'm going to use the same equation. Now here it is going to be least square. It is going to be least square, but in panel, I am going to write it here as fixed. In panel, there are two choices, fixed or random, which we have talked earlier, fixed effect or random effect. So let me see first fixed effect. Let us see, say okay. Now this gives me the fixed effect model. Now in fixed effect model, dependent variable is different as GDP, and difference capital expenditure, difference debts, but debts are not statistically significant even in the fixed effects. Even in the fixed effects, debts are not statistically significant. Okay, so R square has increased 0.69. Earlier R square was not so much. So earlier R square has increased. So this is your fixed effect. So let us say view and fixed and random effect cross-section effects. Now in cross-section effects, these are the effects, that is, they are the constants which are coming up. 13271.35 for the first state, minus 4611.885 in the second. Similarly, so they are coming as this. Okay, they are the fixed effect. Now view we'll go to estimate equation. Now we will use panel options. Panel options, here we will use random. Here we will use random. We will say okay. So okay, again here debts are not statistically significant. Capital expenditure and time are statistically significant. R square is 0.4 and Durbin-Watson is 0.54. So there is no much issue on this. Now, should we use, this is the model. So what is the equation? Equation is simply difference as GDP equal to minus 12295.40 plus debt difference capital expenditure 1.460772 plus first difference debts 0.06, but this time 2264, but the debts are not statistically significant. Now, which one we should use? Should we use a random effect model or should we use fixed effect model? Now, to run this Hausman test, I told you Hausman test is used for seeing whether we should use fixed effect or random effect. So we will have to keep it here random effect, because if you don't keep the equation random effect, then it will not run it. So let us say fixed and random effect here, and then fixed and random effect testing here. Fixed and effect random test here. Fixed random effect testing here. So let us see the correlating random effect Hausman test. We will run Hausman test. Okay, hypothesis. Random effect model is appropriate. Alternate hypothesis, fixed effect model is. Now, because the probability is this 1, It is 1 coming as 1. So it does not reject the null hypothesis. So we will have to use random effects model. Thank you very much. Thanks for listening to me. If you have got any questions, you can ask. Thankful to those whom I am referring for this study. 3 names are mentioned here, but there are many more whom I have referred, whose names have not been given here. But all the experts, they need all appreciations. Thank you very much. You may submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments for your work. Thank you.